Yeah, g'day, Mark here, and welcome back to my channel. The sort of old milling machines that most of us can afford to have in our workshops generally have pretty slow spindle speeds. Our mill spindles don't really have enough RPM for tiny mills or engraving. So there's lots of different ways to boost that speed, like bolting an electric high-speed spindle beside the main spindle, or making up a belt drive reduction like the one from Precious Plastics Romana. I'll leave a link. But then within 1 week, my wife gifted me a Gur wheel pneumatic spindle, very high speed, more for grinding. I'll do a video on this at a later date. And Martin in Berlin gifted me a Henninger high-speed spindle because he decided it didn't work very well. And since I was always spindle speeder curious, I figured I'd give it a go and see how it works. So this model's got a replaceable shank, a 5:1 planetary gearbox, and ER16 collet nose. Now over the years, the data plate sticker for this has become a little bit damaged, and I couldn't really clearly read the type. So I reached out to Henninger, and they got back to me that this is actually a type 813, and they sent me the manual for it, which was very nice of them. It's rated for 20,000 RPM with a 20% duty cycle, 15,000 with an 80% duty cycle, or 12,000 RPM continuously. Now opinions seem to be quite divided on these mechanical spindle speeders. Some people think they're too noisy and too fragile and generally go for other solutions. I've always been curious, so I really appreciate that Martin sent me this one, although he decided he wasn't happy with it. He was trying to use it for milling and felt that it didn't have enough stiffness to give good surface finishes. What I'm going to use it for initially is engraving, and we'll see what it's like. So I do think it's pretty funny that Martin said that about this, but let's just have a quick look and see where that chatter might have come from. I'm really not seeing any run out in the spindle. That really doesn't seem to be it. I wonder if it's play in the spindle. So end float doesn't seem to be the issue. Just double check that. No, I don't really feel any end play at all there. Now before we can get to the engraving, I'm about halfway through making a set of tool holders for my lathe. These are the standard tool holders. There's 2 facing tool holders and 2 extended length tool holders. Now first up, I'm going to do the 2 extended tool holders. Just going to need to touch off again at this corner. Okay, I used a draft version of the program which didn't have a deep enough Z height for the countersink, so I'll have to redo those. I'm hearing a kind of a ticking noise from the spindle, but I don't think it's a bearing problem. that's been rubbing. I think what's happened is this is supposed to be bonded inside that cover. This is all just plastic. And I think that's become debonded and fallen down and just sitting on the fan. I'll give it a good degrease and try and glue it back in. Right, I reckon this is a good job for super glue. Okay, glue's dried. That sounds better. So did those go all the way through? Right, 2 down and 2 to go. Nice. I kind of like my tool holders identifiable, so let's engrave them. That's too big. So for engraving, I've got one high-speed steel D bit with a blunt end and one pyramid style, which is also chipped. But I do have one more carbide blank, so let's grind up a D bit. So here's the setup on my tool and cutter grinder. I've got the carbide blank held in an ER collet. Need to lock that down. Set the cup wheel backwards so that the diamond cutting edge is cutting into the D-bit's cutting edge, so I shouldn't get breakout. And I've set the base over at 30 degrees to make a 60-degree point. Okay, that point's not quite formed, so let's give it a bit more. Right, that's the cone angle now done. So now to do the primary relief, we need to grind away a bit more and then grind away behind. Right, so I've now got the required asymmetry there. There's a cutting edge with some back rake and the rest of the tip is relieved. So now I just need to put a side clearance on the tip and a bit of back rake. Now I don't want to overdo this because I want a nice fine engraved line. Right, well I hope I didn't take too much off the tip there. This is probably going to give a bit wider line than I was hoping for, but let's give it a go. I think I'll start with just doing a test piece. Oh, I've got the wrong pull stud on that one. I had the long pull stud in it, but that's for BT, which is a different flange height. So I need the short one, which is for SK. I need to reset that point. Now, because I'm recycling some existing tool paths that were referenced off this corner for this tool, I want to put them down here. I need to just offset my origin. It's going to end up 12.5 minus 7. I'll just try and increase the contrast for the letters a little. Use a bit of bluing salts on it. The manual for this also requires a 10-minute warm-up at 1000 RPM before you use it.
11 minutes later.
Okay, it hasn't got hot at all. Right, let's try and see what happens when I engrave this bit. I've just adjusted my touch off. Let's take another shot at that. Well, that looks terrible. That's some pretty darn fugly engraving. It's at least too wide, so let me pull out the engraving D bit, regrind that and try and put a smaller tip on it and see if we can make anything better. Yeah, I think I definitely made too blunt a tip on this one. All right, well there's the next attempt with now a hopefully much smaller tip. Let's see what that works like. That's significantly better than the first one. Still thicker than I would like it to be, but I'm guessing that's maybe run out. I wonder if I could get that tool even sharper than that. Definitely usable like that, I'd say. Not quite sure why it looks like I'm getting a bit of an offset. The one looks like it's dropped slightly lower than the 0. Looking back to the original tool holders I made, they also have that same issue. So I guess it's not an error in the tool, that's an error in the tool path. Now that those toolpaths are sorted, I can go into production. The first thing I'll do is just put all the bosses in place. And then the final op is going to be the engraving. What I'm seeing here is the 0, it cuts as a single path, but the 3, I think it went back over the path a second time. Now, is that number 3 as crisp as number 1? Nah, not really. The real tip does have a slight bit of wear on it, so let's sharpen it and see if it cuts better after a sharpening. Okay, so that is now a little bit crisper. From a typical viewing distance, even the number 3 doesn't look bad. Okay, that must have broken the tip off because it didn't finish its letters. That's kind of annoying because I've only got one 3-phase power supply in this room, and that means I have to shut down the mill to plug in the tool and cutter grinder, sharpen it, and then start the mill again. The good news is that I am getting much faster at sharpening a D-bit. This is now the 3rd time I've done a resharpening. Once was a sharpening and twice was tips breaking off. It could well be that this spindle speed is worn out and has bad bearings or something, and therefore is not supporting the tip well enough. Then again, it's equally possible that I'm terrible at sharpening D-bits, and that's the problem. Yet another root cause potential for why I'm breaking off the tips could be the collet. Another source of issues might be the ER16 collet. If it's got a lot of run out, that would also break off tips. Okay, I must have the tool height slightly off. Maybe I'm not quite flat through there because I'm still not quite touching it. Okay, I was just about to engrave the next one when I set up for macro and realized, wait a minute, looks like I've got a chip on the leading edge. So I need sharpening again. Right, to get this job finished, I think I'm going to need to drag my Clarkson tool and cutter grinder over into another room that's got a three-phase power supply so that I can have both machines up and running at the same time, because it's obvious I'm going to have to resharpen this D-bit quite frequently. Why is that? Well, it could be that the bearings or something on the spindle speeder are worn out, but then again, it could just be that I'm using a crappy collet, or I don't know what I'm doing. Could also be the case. But you can see where I'm going with these, and I must say having the spindle speeder certainly speeds up the engraving. Normally with 4000 RPM I'd be down at about 15 millimeters per minute, whereas here I'm doing 100. Once I've got them all engraved, I'll probably throw them on the surface grinder and just take off that extra bluing that I slopped around the outsides and start making the adjusters. Thanks for watching.